Okay, we're on lesson 34, unit 6-4, page 368. We're going to talk about the amplitude and period of sine and cosine functions. Now, we begin by talking about sine theta and cosine theta. And what we've done now is we're saying, okay, we're going to focus on this part and we're going to look at the sine and cosine of a sine theta, which has to do with amplitude, which we've talked about a little bit. And then we said, okay, then what we're going to do is we're going to add a k to that. And we're going to see what effect putting a bigger number there has. And so now we're in the form of a sine k theta. So we're dealing with amplitude and the k situation, which is going to affect the period, and we'll talk about why. And then we're going to say, well, let's take that a little bit further, and let's deal with the amplitude and the period, but now let's do a phase shift or a horizontal shift, because we've already talked about that's going to shift left or right if it's inside the parentheses. And then we're going to say, well, then let's add an h, which means then we're going to talk about a vertical shift. So then we would have amplitude, we would have period, we would have phase shift or horizontal shift, and then we would have vertical shift, which is as far as this book is going to take us. But it is going to kind of introduce what would happen here. And what would happen here, we know, is going to be that inside, like these two numbers, what's going to happen is that it's going to mess with the sign value in the reverse order of operations. Normally, we just look at it in these two situations. We got something being multiplied and something that's being subtracted. And so what's going to happen to my x is that I would add and then I would multiply. But you throw a little number right there and you're like, how do we deal with that number right there? That number right there could kind of be factored out and stuck over there. The b, because it could be factored out of the b and the c, we could actually take it to the outside and it would cause some crazy stuff to happen. Change the amplitude, see? So we're not really going to leave b in there. It's going to be factored out and become a part of a, and that's going to change your c value over there too when you factor that out. We're not really going to go quite that far, but it could go that far. So for our general studies, we're just going to kind of leave it at this. We may have a problem that shows up in our homework or so where there's something there, and we're just going to factor it out, and then it'll be right back to the step before that. Okay, so today we're going to focus on amplitude and period, and some of this other is going to be coming up in lesson 35. Okay, now, we said that in a normal sine wave, what is the amplitude? It's 1. And what is the sine of 0? 0. And then the sine of pi over 2 was 1, and the sine of pi was 0, and the sine of 3 pi over 2 was -1, and the sine of 2 pi was 0, and we had a normal sine wave that was doing that. So hopefully we can quickly run that through our mind. If you can't, then you need to study so that you can quickly run that through your mind. Now, the amplitude is 1. Now let's talk about this. What if I had made this y equal negative sine theta? All I did was change the sign to negative. What's that going to do to all my y values? It's going to make them negative, right? So what that would be a reflection. You understand, if we made it y equal negative sine theta, all it would do is reflect across the x-axis. Did that change my amplitude? No. What's my amplitude of the red one? It's still 1. Amplitude is the height of the wave. The height of the wave is still 1. Doesn't matter if we went down first or up first. What is the height of sine? 1. So the height of sine theta and the height of negative sine theta is the same. It didn't matter if it started up first and then down, or down then up, the height of the wave is still the same height. That means that if a sine wave has an amplitude of 1, we had a sine wave, y equals sine theta. And we're trying to write an equation, and we're given the fact that the amplitude is 1. And that's the only transformation that we're making to the sine wave. Then what would the possible answer choices for your sine wave equation be? A sine wave with amplitude 1, and you've made no other transformations. It means that your A could be 1 or negative 1. That means if we say amplitude is A is 1, that means that the A could have been either positive 1 or negative 1. So my choices would be y equals sine theta or negative sine theta. So with a given amplitude, we get two possible choices of an equation. The positive of A sine theta and the negative of A sine theta. Okay? So let's just say, okay, let's say we had a sine wave with an amplitude of 3. Now all that really means is that it went from negative 3 to positive 3. It either started at 0 and went up 3 and then to down 3, or it started at 0 and it went down 3 and then up 3. Which means my two possible equations, if the only transformation I've made is I've said it has an amplitude of 3, would be 3 sine theta or negative 3 sine theta. So I'm going to make the A, we're putting it in the form of A sine theta, where A represents amplitude, or the thing that would create that. So if amplitude is 3, then A would either be 3 or negative 3, you see. Okay, any questions on that? Okay, so let's look at our little homework. Question number 13. Homework sheet question number 13. I'm going to erase this out, and we'll take a look at that. Oh, did we skip 7 through 12? Oh, that's where I meant to be. Wow, that was weird. Interesting. Yeah, we're on number 7. How's that? That's where we're supposed to be. Sorry. It says state the amplitude for each function, then graph each function. That's better. I was getting ahead of myself there. So number 7, it says y is equal to 2 sine theta. If the equation is y equal to 2 sine theta, then what is the amplitude? The amplitude is 2. Now that's the only transformation. It's the only transformation. So what's going to happen to my graph? The y values are all going to be doubled. So if we know what the original function looks like, all we have to do is double the thing, right? If we're talking about sine, instead of going from 1 to negative 1, if the amplitude is 2, your wave is going to go from positive 2 to negative 2 rather than positive 1 to negative 1. We're still going to divide it into pi over 2, pi, 3 pi over 2, and 2 pi just like we did before. The period is 2 pi. We're going to divide it into 4 chunks. 2 pi divided by 4 is pi over 2. We're going to make pi over 2 jumps. And then we go to memory work. What was the sine of 0? 0. But what if we double that? Still at 0. What was the sine of pi over 2? 1. Well, we're going to double that, so it puts us at 2, right? What is the sine of pi? 0 doubled is 0. What is the sine of 3 pi over 2? Negative 1, but we're going to double it to negative 2. And what is the sine of 2 pi? Back to 0. And so we can pretty well easily graph that. All we did was used our unit circle and doubled all of our y values, right? Any questions on that? So when we increased A, it didn't stretch it to the left, it didn't shift it up or down, it just increased the amplitude, okay? Your maximum and minimum values. Any questions on number 7? Now, let's look at the next one, number 8. We're going to talk about it. We could build a table on all these if you wanted to. You can always build a table to get your graph. But number 8 was y equal negative 1.5 sine theta. And we want the amplitude. Now, amplitude is really the absolute value. We're talking about how high is the wave, which is distance. And there's no such thing as a negative distance. And so when we refer to the amplitude, we're not going to use negative 1.5. We're going to use positive 1.5. It's just telling us that our wave is 1.5 tall. And so really what's going to happen here, I'm just going to use the same one. Instead of going up to 2 and down to 2, it's going to start at 0, go up to 1.5, but it didn't start there, did it? Did you notice that? Not only is it going to change the height from 1 to 1.5, that's going to reverse all of them, all the signs. So when we think about what it would have been, we could say, well, if we were at pi over 2, it would have been 1. But because of the 1.5, it's now 1.5. But instead of positive, it's negative, so we're really at negative 1.5. May understand that? I'll do it in red. And the 0 is going to stay 0. This one would have been negative 1, but the 1.5 means it would have been 1.5, but the negative means it's up here instead of down there because it changes the side it was on, and then we're back to 0, and so that one went down and then came up. It went to 1.5 instead of 2. How do you understand that? Now, if you don't understand something, ask. I'm going to let you finish that, and then I'm going to build a table just because I think we probably should, just in case somebody didn't get all of that. A table makes you see what's in her head, basically. I think I'll leave that over there. I don't know what I want to erase. You've got your graph. I'm gonna take this out up here. We don't need that anymore. It might do you good to do this. And this is what we're going to start developing a little bit. We're going to say theta, and then we're going to say sine theta, and then we're going to say negative 1.5 sine theta. This is the way I suggest you build a table if you're going to build a table and try to look at these parameter changes. Our numbers we like for sine and cosine are 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So here's our brain thinking. What was the sine of 0? So what's negative 1.5 times 0? 0, so we're at 0, okay? What was the sine of pi over 2? 1, but we need negative 1.5 times 1, which is negative 1.5, and so it ended up right there. All right, I mean, you can build a table. Well, that's all we did is did that in our head, you see. What is the sine of pi? 0, negative 1.5 times 0 is 0, so we're back to 0. The sine of 3 pi over 2 is negative 1. Negative 1.5 times negative 1 is positive 1.5, and so that's why that one ended up there. The sine of 2 pi is 0, negative 1.5 zeros. So again, we could build a table and graph these, but you still need to know, if I don't let you use a calculator, you still have to know your unit circle stuff. And just write it down on paper instead of trying to do all that in your head, you see. All right, any questions on number 7 and 8? So that takes care of amplitude. All right, so now we're going to put our focus down at the bottom, which is in y equal a sine k theta. Now we're adding a k. Or y equal a cosine k theta. The period is 2 pi over k, where k is greater than 0. We're going, what are you talking about? Why is this happening? What's going on? Yesterday, or the day before, we discovered all this stuff in the last lesson. And we said that this little k is like having this in parentheses, right? And it eventually would be k theta plus c. And this is being multiplied, and it's inside. So what's going to happen is my x's are all going to get divided by that number. Now, my x's are going to go in a normal period to 2 pi. That's normally how far your x's go in one cycle, right? One period is normally 2 pi for x. And so if I have a number there, and I'm going to undo on the inside with the inverse operations, that means I really need to divide by that. So my period of 2 pi needs to get divided by that k, because we're going to undo multiplication by division. So to find your period, you go 2 pi divided by k, which follows our parent function transformation stuff. What's inside the parenthesis happens to x in the inverse order of operations. So we would undo multiplication by division, so we divide by k. And that's going to affect the period. Okay? So if we look up here at this picture above, if I said, okay, I'm going to take the blue one, that was the normal one, right? Well, let's just go back to a normal sine wave. I think that would be better. I'm going to have too much junk coming at you at one time. A normal sine wave would have been positive 1, negative 1. And at pi over 2, and pi, and 3 pi over 2, and 2 pi, we would have started at 0, gone up to 1, came back down to 0, gone to negative 1, and then gone back up to 0, and we would have had that. Now, if I multiply inside here by 4, let's just say we had y equal sine 4 theta. Then what's really going to happen? I'm going to end up, because this is understood to be in a parenthesis that looks like this, I'm going to end up undoing multiplication by division, and so my period is going to get divided by 4, and so my new period is going to be what my original period always is, 2 pi, divided by 4, which is pi over 2, which means that that entire blue wave is now going to happen by the time you get to pi over 2 instead of by the time you get to 4. It'll happen 4 times within that same period. Okay, now let's think about that. If we wanted to graph that, if we want to graph it and it's going to happen in pi over 2 and we want 4 chunks, it's going to happen in pi over 2 and we want 4 chunks, what do we have to do? We have to divide by 4. Well, if we divide by 4, we get pi over 8, right? That means every pi over 8, some major thing happens. Okay? Everybody with me on that? Our period is going to change to pi over 2. So our new period is pi over 2. That means this entire wave happens by the time you get to pi over 2 instead of time you get to 2 pi. But if it's all going to happen in pi over 2, I need 4 little marks between 0 and pi over 2. Because we're going to have all these dots, right? Okay? And they're going to end up 1, 0, 1, right? 0, negative 1, 0. But all that's going to happen by the time you get to pi over 2. Now the gaps, so if I take 2 divided by 4, I'm going to get 8. So it happens in eighths. Okay, so what that means is I've got a pi over 8 right here. And then I've got a 2 pi over 8, which is a pi over 4. And then I've got a 3 pi over 8. Now, I'm going to write these out. You've got pi over 8. You've got 2 pi over 8, which is pi over 4. And you have 3 pi over 8. And then you've got pi. And we've got 0. So there's your 5 markers, you see. 0, pi over 8, pi over 4, 3 pi over 8, 4 pi over 8, which is pi over 2. All right, what happens at the first marker? 0. What happens at the second marker? Positive 1. At pi over 8, we're already to positive 1. What happens at the third marker? Back to 0. What happens at the next marker? Down to negative 1. What happens at the next marker? Back to 0. The entire cycle happened in pi over 2 instead of 2 pi. So what happened? That k, that 4, it means we have 4 times as many waves, but that also means that each wave is a fourth of the distance it used to be. You see, 4 times as many, but they're 4 times as short. All right, they visualize that and see the connection between that and the parent functions. Okay, so that takes us to number 9 and 10. Now, we threw some fractions in here because that's just the way things are. That got kind of crazy. It'd be nice if I could, let me see. I doubt I can. If I could just reverse some, oh, that's ugly. Is it going to reverse that for me? No. Oh, that would be good if I could go back to the original. I should have saved it. Oh, well, we kind of have a mess. We'll just get rid of it. That's probably better. Start over. Too much junk. Okay, so we learned then that to find the new period for sine and cosine, you take 2 pi divided by k, right? That's your new period. So we know that. So that's really all we need to know. So if we have y is equal to theta over 4, cosine theta over 4, if we were given this function to begin with, and we say that k is equal to 1/4, you understand that k is equal to 1/4, right? Can you see that the k is 1/4? It gave you that. There's a 1 here and a 4 there, and if you take that, there's your 4th. It just kind of went ahead and said, okay, here's, in case you didn't notice, it's 1/4. Or maybe I wrote that in there and it wasn't on your paper. Did it give you k equal 1/4 on your paper? Oh, that was in my notes. That's why. Okay, so we gave you y equal cosine theta over 4. And we can identify then that the thing that got multiplied to theta is 1/4. Now, so we know our k. So how do we find our period? The period is 2 pi divided by k, which is 1/4. Now that's going to give some people a hard time. We need to divide by 1/4. So how do you do that on paper? Well, we have 2 pi over 1 divided by 1/4. I'm just going to work it all out so we don't miss it. 2 pi over 1 divide 1 over 4. This is called a complex fraction. To divide by a fraction, you multiply by its reciprocal. So we got to go back to our basic math. How do you divide by a fraction? You multiply by its reciprocal. So we're going to have 2 pi times 4, which is 8 pi. So my new period is 8 pi. What does that mean? 8 pi, half of 8 pi, in the middle, 1. This is cosine, -1. Cosine starts at 1. It's going to take all the way to 8 pi before you make one cosine wave. Remember, cosine starts at 1. See what happened? I tried to mess up on my 4 pi. I needed to go down. All right. Everybody see what's going on there? It didn't ask us to graph. Oh, it did say graph. I didn't graph in my answer key. I need to go back and graph. So that means that it cycles in 8 pi. Why did I make it units of 2 pi? I need to take my period and divide it into 4 chunks. 1, 2, 3, 4 chunks. And if I were to take 8 pi and divide it by 4, I would get 2 pi. So I need 2 pi jumps. And you're back to your same numbers. Just sticking them in there. Any questions on that? Okay. Everybody good so far? Okay. All right. Number 10. This is kind of neat, isn't it? We said if the entire period is 8 pi, and we're trying to, if we were going to build a table, right, we would have 1, 2, 3, 4 things, 5 gaps. So we want to go from 0 to 8 pi. Well, we're saying I need 4 jumps, 1 jump, 2 jumps, 3 jumps, 4 jumps. So I'm going to divide that by 4, which means each jump needs to be 2 pi. So I need to go 0, 2 pi, 4 pi, 6 pi, pi, to make 4 jumps and get my way from 0 to 8 pi. And I'm still going to have my 1, 0, -1, 0, positive 1 from memory. Yeah. That makes sense? Good stuff. Okay, let's look at number 10. Number 10, we have, this one got harder. Why did this one just get harder? Because we've been dealing with quadrantal angles for a long time. 1, -1, and I jumped off of that. Now we're going to be dealing with halves and square root 3/2s and uglier stuff. But reality is, that's just the way it is. There is some uglier stuff. So we have sine of 30 degrees. You go, sine of 30 degrees. Okay, that's a half. But we haven't been dealing with degrees. We're dealing with radians. So what we would really like to do is rewrite this in radians, wouldn't we? Isn't that what our rule applies to? Our rule is not applying to degrees. Our rule is applying to radians. And if we will apply it to radians, then we don't have to deal with the half and square root 3/2 and all that. We can make our way back to the original sine wave or cosine wave and choose quadrantal angle stuff, you see. So we're really going to say, well, that's really, how do you get it in terms of pi? You take 180 divided by that number, and that becomes your denominator, right? Remember that? 6. 180 divided by 3 is 6. So that means that's the same as pi over 6. So we really have sine pi over 6. Right? To find the radian equivalent, we take 180 divided by the angle measure, and that gives us the denominator. So what does that mean to us? It means it's really y equal sine of 1 pi over 6. In other words, k is equal to 1/6. Well, that means we can just plug it in the formula. And we really can use our quadrant tool angles to build our table. They say we did that. So we saw the sine 30 and we thought, oh no, we got all this other junk. But no, we don't, because we just need to write it in terms of pi. Then we can see our k, and then we're really doing the same thing. We want to find our period. Now, how do you find your period? Well, the normal period for sine and cosine is 2 pi. And to find the new period, you take 2 pi divided by k, and my k is that 6. So 2 pi divided by 1/6. So we changed our degree to radian so we could see our k. Okay. I messed up. I'm sorry. Just a second. Now I'm thinking, that's crazy. Okay, obviously, the reason I paused and I was having problems is there's not a variable in this. If you have y equals sine x or y equals sine theta, then you have a variable. So then you could build this table of values and come up with a whole bunch of answer choices. But I wrote a problem number 10 and I didn't put a variable in it. That means this is not a sine wave. This is a single answer. And we said to begin with, sine 30 is a half. Well, that's all there is to that one. It's just a half. And so it's not a situation where we need to be talking about amplitude and period, because this is not a function. This is a single answer. Anyway, kind of a bad problem to throw in there. I kind of made up a bad problem. So anyway, so number 10, y equals sine 30. There's no variable, so there's no function, so there's no graph of a wave. We know from memory sine 30 is a half, so that's all there is to number 10. Any questions on that? Hopefully if you tried to do that, you would have gone like I did and said, hey, this is goofy, there's no variable, and then pause a little bit and think about it and go, okay, yeah, that was weird. Okay, any questions on number 10? I think we'll stop there, and then we will begin on number 11 next time.